So what I've been trying to say is there's an individual, you have logical thinking, which you generally become good at. The logical thinking skill is what you get good at math, and that's how you become good at computer science. You don't need to be good at math to be good at computer science, and that's how you figure out whether you want to do computer science at college and all those things. This is the first part that I wanted to mention. So I explained that this is a logical way to arrive at why to do computer science. But there could be a lot of other beliefs. Hey, I know someone else doing well in a computer science job, so let me pick it as well. This is called mimetic thinking. As human beings, we might not be very good at thinking of original thoughts ourselves. I don't think I'm very good at that. I follow a lot of people, I listen to a lot of people, I read works of a lot of people where I take their thoughts, I steal their thoughts, I copy their way of thinking. So that's how we become good. So if computer science works out for a lot of people, high paying career, you are generally good at, you become good at problem solving and all the useful skills that you can apply outside in life as well. And it might not be necessarily this diagram by itself. I am just pointing out one way of thinking of how you become good at this. Now, one surprising observation that I have is, one second, let me just move this to the left a little more. I don't think I believe people are asking the wrong question. What do I need to know at school, or what do my kids need to know at school to become good at computer science? I just told logical thinking. You can acquire logical thinking skills. Any skill, when you are born, you are not born with any skill. You have an affinity towards some skills, you get better at it. Math is not the answer. Surprisingly, in my very strong personal opinion, it is another subject, or I'll probably put it over here. It is another subject which I think is supremely important to becoming good at computer science. It is nothing other than your first language. For me, my first language is in English. A lot of things are good in English. It is knowing the language that informs how you think. I don't know the quote correctly, so let me just. Here is George Carlin, a famous stand-up comedian, thinker, and all those things. His quote is, "We think in language. The quality of our thoughts and ideas can only be as good as the quality of our language." I think this is a very profound quote. A lot of times we think English is all about how you are perceived, how polished your English skills are, how good your grammar. It is a lot of things. I'm not getting into it, but I am of the opinion that if you want to get better at thinking, your primary language, it need not be English. It could be any of your mother tongue or your primary language at school. One language you need to master. You need to get extremely good at grammar. You need to be extremely good at vocabulary. You need to read a lot of works in that language, because only then you grow as a human being. To grow as a human being, you execute actions. Actions are driven by thoughts, and thoughts, I think, are driven by language. Over here, this is where I don't know if George Carlin was the first person who came up with this quote, but I deeply believe in this quote. We think in language. The quality of our thoughts and ideas can only be good as the quality of our language. This is super important. One of the reasons why I enjoyed computer science right from school, college, and adult life is I have been very interested in my primary language, which in school was English. So it is less to do with my mathematics skills, say for example, compared to my peers, compared to seniors, juniors, and different people. When I have compared myself, how good of an individual am I in computer science, and when I try to rate myself, if I am in some meeting or somewhere else where I am able to provide value to someone else, say for example my boss, my client, other people, compared to other colleagues of mine or peers, I go back thinking, hey, what was the trait that helped me come up with that answer or take the meeting forward, drive it? I believe it is control over a language. It is not only communication. Communication is how you communicate. It is also the formation of thoughts in my head. A lot of them are driven by my extremely strong fundamentals in the English language. And since a lot of code, lot of tutorials are all in English, it just so helps. Since India, a lot of schools have primary language as English, that's very convenient for me. Say for example, if I I was in Poland, Russia, France, and all those things. I don't think I'll be this comfortable programming. There definitely is an advantage, but in terms of thinking, I think English is where I believe it is not a peer, it is a fundamental to get good at computer science. This I believe a lot of people overlook when talking about how do you decide if you are good at computer science. So it is, as I told, all of these are acquired skills. I'll also talk about alternative paths. As I briefly mentioned, this entire thing should be inverted. We'll move on to the next section on what I want to cover. I mentioned earlier, I'm still not comfortable with this drawing tool. Hopefully I should get better over time. Okay, let me actually remove that as well. So what we were talking about earlier, I was saying we think of computer science as a good enough choice to get into the right college and therefore success in life and all those other things. I have not moved on beyond college. I briefly mentioned that you should not think of college as the destination and computer science as the way to reach at it. At some point of time, it should flip. Ideally, after college, you should still be thinking about computer science, engineering, programming, all those things. When I say computer science, I mention all of them. College helps you get better at computer science. Now, what if you do not get into a computer science degree or an equivalent degree, whatever it is? There are two kinds of people. One who take this very straightforward route. I was someone who took computer science. A lot of things very easy. I was able to learn a lot of different subjects that gave me important perspectives which I would not have learnt in the job. Say for example, how do you handle race conditions? For that you need to be familiar with the operating systems. How do you think in distributed systems? All those things. There are courses online, but I had an earlier head start when I read the foundational subjects, foundational books, chapters, papers, algorithms, data structures, all those important subjects that stand the test of time. It's not about the latest technology. I'm not going to talk about React. I'm not going to talk about mobile apps. All those things that will keep evolving. A CS degree, a BTech in computer science or a BE in computer science in India, there are two kinds of degrees. A bachelor's in computer science gives you a lot of quick way in getting good at it. But there are always two kinds of people. You can dissect it both ways. One, you might join a computer science college degree, but you could be completely not okay with the exams. For example, my college that I studied did not emphasize on true learning, it was on rote learning. You had to reproduce information and content. It was not an ideal experience in my opinion. Now, when in such a scenario, what I believe is you have to spend, when college is not, the professors are not really teaching you, you still have the material, you have the guidance, you have the syllabus, you have seniors whom you can consult and you can learn all these things, but you clearly know what you should be doing. That is the straightforward method. So within college, there are two kinds of people. One who get disillusioned, who think that, hey, maybe programming is not for me, computer science as a career is not for me. It is very fair. You can move on to other kinds of career paths. College is also a good time for you to explore. But then people who know that they want to get into computer science and persist no matter what, it becomes easier for them to keep improving in this one aspect. Which aspect? It is computer science. You become better at computer science when you persist with the college syllabus, but still you don't rely too much on professors alone. At least in my personal experience, that was the case. Now, a huge majority of people in the outside world, not majority, a huge number of people in the outside world, they don't take the straightforward path. They don't go through college to become better at computer science. This is again a class of two sets of people. The approach that I see is there is no clear structure. So what happens to an individual is they take this meandering path where they do not know if they are actually proceeding in that right direction. They could be going around in circles, but they might eventually arrive at computer science. So this path is shorter if you do not give up in college. This path is longer. That means when it is longer, a lot more people fall out in between. They get demotivated. They do not know whether they are going to succeed. But at the same time, you explore on your own. You figure out things on your own. That gives a lot of strength in terms of thinking. You become mentally much stronger when you take this route. I'm not recommending one route over the other. Both routes have their own flaw and advantages and disadvantages. I believe taking the college route was easy for me. I didn't want to spend a lot of time outside learning all these concepts, but even then, I believe my knowledge is much smaller compared to someone else who would have learned everything from first principles, from the internet, from books, and all those other things. Now, I mentioned that people drop off. Those who persist, I believe, are better. Now, I would like to sort of get into more deeper understanding on why these people are better. Okay, they did take a longer road, they would have seen more things, but is that necessarily a good thing? Uh, I'm not going to talk about in terms of computer science knowledge. I'm going to emphasize a lot more on the mental strength aspect of it. So I'm not sure if all of you are familiar. There is this Stanford marshmallow experiment that was conducted way back in the 1970s. I believe it started in 1970. So I'll just read this out loud so that you know what this is all about. Stanford marshmallow experiment was a study on delayed gratification, which means you don't seek instant gratification. We can even see what it is: resistance to the temptation of an immediate pleasure in the hope of obtaining a valuable and long-lasting reward in the long term. Delayed gratification, it goes into details. Let not go down that rabbit hole. So there was a psychologist, Walter Mischel, professor at Stanford University. In the study, a child was offered a choice between one small but immediate reward or two small rewards if they waited for a period of time. During this time, the researcher left the child in a room with a single marshmallow for about 15 minutes. So the professor gives the child a marshmallow, goes out of the room, then comes back 15 minutes later. If the child did not eat the marshmallow, the reward was either another marshmallow or a pretzel stick. Say for example, the kid doesn't like a marshmallow, it likes pretzels or something like that, depending on the child's preference. In follow-up studies, the researchers found that the children who were able to wait longer for the preferred rewards, I believe if the children were told, hey, if you can wait for 15 minutes, I will give you more. The children who were able to wait longer for the preferred rewards tended to have better life outcomes. You can, it's all debatable. You can say, hey, what is a better life outcome? In an objective manner, your career path, your salary, or your position in society, all those things are a good reflection on success in society. So over here, better life outcomes, it is like what you want. You want to be good at something, have you achieved whatever you want to achieve? As measured by SAT scores, educational attainment, body mass index in terms of fitness, all those other things, and other life measures. A replication attempt with a sample from a more diverse population over 10 times larger than the original study showed only half the effect of the original study. So there are some parts that are still debated. The replication experiment suggested that economic background rather than willpower explained the other half. So it is not just practicing delayed gratification, it is about other benefits in society that you have because of effectively our parents being rich enough. Can you afford things? Can you afford a laptop when you're at school? Can you afford a teacher? Can you afford a course? In terms of modern society, that's how I would see things. So say for example, if all you have is a smartphone of your parent or something like that, it is generally hard and you cannot write code. So there is definitely this economic angle to it. I agree with that. So again in 2020 they challenged the entire thing. It's still up for debate. But this is where I believe practicing delayed gratification is a huge important aspect of developing mental strength. I believe that is where I'll cover mental strength, how to have the right attitude later. You just have to keep this in mind. In terms of delayed gratification, can you get good at delayed gratification? Now, what explains this people falling off? So I just told there are people who succeed, finally reach wherever they want to reach, they get good enough as people who persist down the college route, and there are some people who drop off, right? Can this be summarized into a simple concept? I believe it is survivorship bias. So many of you might have encountered this diagram. So in World War II, they examined the planes after they ran those planes in the war, and they examined where the bullet holes were. So red clusters, my bullets are hitting only over here and they are surviving what does it actually mean and all those things. They were trying to understand this data when they examine the my plane goes to the enemy warfront, gets riddled with bullets. When it lands, I examine where those bullets are and I see what happens. So this unique pattern where you see over here and over here in the front, there are no bullets. Why are there bullet marks only all over the plane? You need to practice something like inversion of thinking. It is not that people are shooting bullets only at these regions. It is that the planes that have bullets only in these regions survive. If a plane got shot over here in the wider section of these areas, they usually crashed. So when you interpret the data, what that means is, hey, as long as planes don't get damaged in the critical parts, in the not critical parts, if they get hit with bullets, you end up with a pattern like this. So I told about planes going into the enemy territory, right? Not all planes come back. So let me read survivorship bias or survival bias. Is the logical error of concentrating on entities that pass the selection process. The selection process here is what? The planes that crashed versus the planes that returned. Planes that crashed in enemy territory versus planes that returned back to your friendly territory, while overlooking those that did not. So I'll repeat that again. Is the logical error of concentrating on entities that pass the selection process while overlooking that did not, or overlooking those that did not. This can lead to incorrect conclusions. Incorrect conclusion, what will I do? Immediately think when I look at this, hey, it is impossible for a plane to get hit over the fuel sections or the engine motors or whatever. I'm not a aviation engineer. I don't know fully what these parts mean. Survivorship bias is a form of selection bias. Selection bias, again, it was a class of bias. We'll go at that much later. Let's not go into that right now. That can lead to overly optimistic beliefs because multiple failures are overlooked. This I believe personally when we form opinions on several things in life, there is this personal bias as well. Hey, I survived this, so it should work for everyone else as well. A lot of things might have gone right, or when you look at successful startups, successful businesses, there's a saying that 90% of startups fail. So when you try learning lessons only from the successful startups, and when you ignore the failure startups, you make the same mistakes that the failure startups did. So it's important to have good knowledge of both. So that can lead to overly optimistic beliefs, as I told example of successful startups, because multiple failures are overlooked, such as when companies that no longer exist are excluded from analysis of financial performance. I look at the status quo, I look at the list of companies, hey, these companies are doing so and so, such and such process, let me do better. But what if several companies try to do something better? Two examples that I can think of is, hey, all these social networks, Facebook, Instagram, TikTok, Twitter, all these social networks do not do this. Let me try a new approach. It is very rare. There are so many social networks, social network companies, social network products that have failed. The graveyard of such companies is enormous. Unless you go and read about all of them, you will be making the same mistakes in your new social network startup idea. Another example is using the wrong technology because you think, for example, force fitting technology. This is solution in search of a problem. You have a technology like blockchain, or you have technology like Web3, NFTs, and all those things. There were only endless failures. Okay, let me not digress from that. It can also lead to the false belief that the success in a group have some special property rather than just coincidence. Hey, a lot of things in life are just coincidence. So there is this saying, coincidence, not coincidence. Coincidence is not causation. Correlation is not causation. I'll get into that. A lot of time when we plot things on a graph and we see similar results, we think one implies the other. I was telling math, knowing math implies you become good at computer science, right? I explained how both actually involve logical thinking. You need not be good at math, but you can still be good at computer science. So here's the quote that I was searching for. Coincidence as is correlation proves causality. Correlation does not imply causation. If two things look similar or something like that, one does not lead to the other. Imply causation. Causation means there is a cause and an effect. You have A, you have B. They might be similar. A might produce similar results as B, but you cannot say A leads B to happen. A is causing B, you cannot infer that. That is a bias that we always do. Another kind of survivorship bias would involve thinking that an incident happened in a particular way because the only people who are involved in the incident who can speak about it are those who survived it. Okay, this is getting more and more complicated. Let us not go deep into this. Coming back, over here, I told those who survive, the survivorship bias, they, in my observation and whatever I've read online, they are generally better than those who take the straightforward college route, because there are so many people who drop out. Maybe only 5% succeed. I don't have data on what it is. My estimate would be 5% or less than 5% actually succeed. 95%, when they take this non-college route, they get discouraged, they get distracted by other things, they might drop out of choosing computer science as a career path, as a future, and other things. Now, those who succeed is a survivor bias. Survivorship bias is what I feel in terms of. Just a second. I have a notification. Okay. So, those who survive might end up being better. Now, okay, that's all fine from a bias point of view, from a how do I say, philosophical point of view or something like that. Can you tell me something tangible, how these people get good, how these people are better? Now, what if there are good things over here that these people learn and is not available? Maybe going through this entire circular path taught you something that would not have taught you. There are some excellent benefits in these regions where there was tremendous growth that you may not realize. What if when I'm taking the college route also, I can take this massive learnings in addition to the syllabus, the mental model, the way you approach things, and these ways of thinking, these paradigms. If you adopt these, how can you have a successful career in computer science? This has been observed and codified in a word called the hacker culture. I believe right from the 60s and 70s, there are different interpretations. The word hacker, as now today journalists or modern media have stolen that word to signify something else. I believe all of this is codified in the hacker culture philosophy. I'm not sure if I am able to fully follow in practice, but I want to follow the hacker culture in practice. So let us get into what the hacker culture actually is. The hacker culture is a subculture of individuals who enjoy, often in collective effort, not in isolation, with peers and other things, who enjoy the intellectual challenge of creatively overcoming the limitations of software systems or electronic hardware to achieve novel and clever outcomes. So, putting it in simpler words, you enjoy the process of solving problems, and you enjoy it while doing it with peers. That is what the hacker culture is. Are you someone who enjoys solving problems? If it so happens that the problems that you solve are in the software space or electronic hardware space, it is considered hacker, but you could be solving problems in different manners. Unfortunately, the term hacker culture does not apply to that. Probably there is an even more broader term that applies to this. Now, getting into hacker culture itself, the act of engaging in activities such as programming or other media in a spirit of playfulness and exploration is what is termed hacking. There is a word hacking. The word hacking is used in modern society today in media, newspapers, everywhere, as bypassing network system, bypassing rules and other things. That is called, especially for nefarious purposes, that is called cracking. Unfortunately, the term, I forgot what that word is. The term got lost its meaning along the way. True hackers still use the word hacking, but people outside the subculture use the word hacking too. It's the literal hack away. What if you have a knife and you chop off, you hack your way through jungles? I forgot what that kind of knife is called, a long broad sword. So that kind of hacking, you are not necessarily following precise processes, rules and other things. You are just enjoying the process. You are in a spirit of adventure, playfulness, exploration, and all those things is what hacking is. However, the defining characteristic of a hacker is not the activities performed, for example programming, but how it is done. So you can have a programmer who says, no, I'm just going to do it like this, this is how it is supposed to be done, there is no other way, I have to do in a rigid manner of thinking. While there is another kind of programmer, second type of programmer, who says, okay, I will solve this problem, but this time I'll take a completely creative route that gives me happiness, fulfillment, learning, all those things when I take that approach. That second kind of a programmer is called a hacker. So it's not the act by itself, but it's how you do that act, whether it is exciting and meaningful for you. Activities of playful cleverness can be said to have hack value. This hack value is very subjective. Your peer group will validate if you do something, oh, is it worthy enough? Is it of considerable hack value or not? And therefore, the term hacks came about with early examples including pranks at MIT. I believe this was in the early 1960s or 1950s or something like that, where after the World War, MIT, but they received, the college received computers. A lot of students and like a lot of students at school, not even part of the college itself, they used to come and explore this lab area where the computer was, new computers were gifted by the, I believe, Department of Defense in the US for scientific purposes. So the academia was not putting it to full use, so the students themselves took it upon themselves to utilize this hardware, and they started playing pranks with it, pranking each other and all. So hacks at MIT are practical jokes, demonstrate technical aptitude or cleverness. So usually there is a morning time where people used to come in and put these machines to use, these large computers to use, but at the night time when these computers were free, these students used to enter and run fancy programs over there and showcase their technical prowess and show off to each other. So demonstrate their technical aptitude and cleverness. The hacker culture originally emerged in academia in the 1960s around the MIT's Tech Model Railroad Club and MIT IA lab way back in 1960s. That's what, 60 years ago. Hacking originally involved entering restricted areas in a clever way without causing any major damage. Now here the philosophy is very important. The philosophy is not to cause harm. It's not to cause harm to the person. Say for example, there is a lab in charge. When you break into the lab, it is not to have revenge or personal animosity towards the lab technician. It is more to show off, hey, I am smarter than you. It's more to show off, hey, there are systems in place, I'll break through the rules and achieve whatever I want. It is completely to do with that. It is not to for any monetary purpose or any for personal gains. That is what this ideology behind entering restricted areas was. Some famous hacks were placing of a campus police cruiser on the roof of the Great Dome and converting the Great Dome into R2D2. If you're not familiar with Star Wars, this is what they changed the dome into something that looks like this. So there was a first generation hackers. There is this excellent book, Hackers by Stephen Levy. A fantastic book. I will recommend everyone. Hackers, Heroes of the Computer Revolution. Very inspiring. It goes through the philosophy on how you do things, how they did things, and how, if you want to progress in your career or generally enjoy the process of doing things, this book is excellent. So the book talks about first generation hackers, second generation of hackers, and so on at different periods of time. And I think Stallman, the creator of GNU philosophy and all those things, an open source hacker way back 60s, 70s, 80s. I think he's still very active, but he was very prominent in the late 80s, I believe. In fact, I think Stallman in the book is called The Last of the True Hackers or something like that. So Stallman is an authority figure. If you are not familiar, I believe he is the creator of Emacs, so many other technology that I'm probably not able to remember right now. So explain about hackers who program. So he is someone who represents the ideology or philosophy of hackers. What they had in common was mainly love of excellence and programming. They wanted to make their programs that they use to be as good as they could. So that strive towards excellence. In non-hacker culture, what similar word that we would say is craftsmanship. A lot of times when we do things, we look for the artist or a woodworker or a sculptor spends an enormous amount of time improving something even if there is no audience for it, right? That is craftsmanship. You do it for the sake of doing things well. That is what I believe hacker culture is all about. They also wanted to make them do neat things. They wanted to be able to do something in a more exciting way than anyone else believed possible and show, look how wonderful this is. I bet you didn't believe this could be done. So that is something like, I forgot, there is a psychological term associated with this. When you challenge someone, they take it upon themselves to prove you are wrong, right? That especially is a very important part of the hacker culture. Hackers from the subculture tend to emphatically differentiate themselves from whom they pejoratively means negatively, mainly in a derogatory manner or some more like a negative thing, called crackers. Those who are generally referred to by media and members of the general public using the term hacker. Hacker is not crack. People in the real world, non-programmers, use the word hacker when they actually mean crackers. But true hackers or people in the programming world know who a hacker is and whose primary focus for crackers is to malign or for malevolent purposes lies in exploiting weaknesses in computer security. So again, we'll not go into the jargon file, hacker file, and all those things. There is a huge history. I will recommend this for everyone. I don't know if chat really works. Hacker culture and all those things. So it seems like that I have digressed a lot, right? One second. Is chat not working? I'm unable to paste. Okay. Okay. Some chat. So if you go over here, Wikipedia, you search for hacker culture, you'll get what it is. So my recommendation is the book Hackers, Heroes of Computer Revolution by Stephen Levy. Now, coming back to where we were. Just a second. We were over here. I told there are things that people learn when a hacker culture, an individual who learns computer science on their own, usually without knowing themselves, unconsciously adopt a lot of practices that the hacker culture has codified. So when you become good at computer science, this is what you do. Now let us take a step back. I want you to completely forget for temporarily what hacker culture is all about and all. Let me move forward. What happens after college? What happens when you finish computer science at college? So there is this enormous struggle that they undergo. They want to really get the degree that they want, or they would have spent a lot of time acquiring the knowledge that they wanted and become good at computer science, right? Unfortunately, what happens is after a couple of months, couple of years, people get disillusioned. They start losing interest in what they are doing. So let me actually open a new file over here to illustrate. Yeah, that's now you take there are a lot of people coming out of colleges who take computer science as a career. Though all of them actually enjoy their job, do all of them feel that they are having true fulfillment in what they are doing. One second, I am just trying to open one material over here. So when there is a lot of competition between them and their peers into getting a degree or successfully finishing their college, scoring high marks at college, getting a computer science paying job, all those things, whether you take the college route or outside the college route, they have a vision, they have a dream that they want to be good at computer science, and they reach a position, they have some skills to actually have a paying job, earning job. I'm not going into academia, I'm just sticking to the career software industry. But at some point of time, they feel that it is not what they signed up for, or they feel that they want more. And after struggling so hard, it breaks my heart to see these people not enjoy what they are doing. So let me actually codify this a little better. How do you get out of that? Exceeding expectations. Oh, I moved from college to a career position, I have a high paying job. For example, let me take this in the high paying job, I'm not having constant promotions. This could very well be something that causes the programmer to be very sad. Oh, I'm miserable. If you go and ask them, they'll ask a list of complaints. So let me classify the list of complaints into 4 categories. The first is almost always remuneration. Hey, I got this when I came out of college, or I just learned computer science, I was happy with it, but I want increasing remuneration, which is a fair ask. I don't expect people to work for free. You should be able to financially take care of yourself so that you can have a family and other things. You are a responsible citizen of society when you think about remuneration. Otherwise, you might be freeloading of others. I'm not getting into whether this is right or wrong. I generally believe this is good. They feel that there is a mismatch in terms of you could be either earning a salary or you could be a consultant earning consultant fees. Remuneration is not good enough. At some point, people do feel this. I felt this at some point of time. But this is not the only factor. One of the other factors, in addition to remuneration, could be good, but then there is this one more feeling called as recognition. Hey, I'm supposed to be perceived as smart. I am a software programmer. I'm solving so many problems. I'm adding so much value to society. I'm adding so much value to the business. Why am I not being recognized? I'll also address this. So, in addition to remuneration and recognition, these two might be there, but two more problems also exist. I'll just move these to the left. I don't know if I have enough space, so let me just keep them in the center. Or do I? One second. Are these grouped? Oh, I think these got grouped. Ungroup them. Yeah, in addition to remuneration and recognition, what other things do software developers want? They want to work on interesting problems. This is something that I have observed in my career. A lot of software engineers, hey, I might have excellent remuneration amongst my peers, amongst my everyone in my entire company. I could be regarded very high by others, but the problems are just grunt work. The job is super annoying to deal with. I want to work on something interesting. Then these three could be there, but everything could be so unpredictable. I'm not sure if I chose the right size to fit in 4 boxes over here. I will say lack of structure. Hey, will I have this job, or will I have a mentor figure, or was my company making enough money so that I can be guaranteed of stability? Can I have structure? So to me, these are the 4 things where problems can be classified by a software developer who generally enters 1 or 2 years into the industry, or maybe even a few months. These are the 4 common problems. Hey, remuneration is not good enough. It's not ever increasing. I am not recognized. I don't have interesting problems to solve. Or even if all 3 are mentioned, I don't know what tomorrow is going to be or what the next few months are going to be. Now, I want to bring the word over here. It is somewhat related to responsibility. I will say ownership. It is your life. You are an adult now. You can't be blaming society. You can't be blaming your seniors, your parents, or others if these are problems. So let us observe what is in your hands, what is not in your hands. So remuneration, you might say, hey, it's not in my hands. Oops. It is in my company's hands, my boss' hands. Recognition, similarly, others do not respect me. For interesting problems, hey, I need to feed myself. I can't keep chasing interesting problems. And when I choose to work in a place somewhere else, not my own business or something. So this is the mindset a lot of people get into. Hey, nothing is on the left hand side. Nothing is my problem. It's all society's problem. I will rather blame others for my current state of misery rather than try to solve all of them. Now, I believe all of this is false. First, let me get into interesting problems. With the entire success of open source software, open source programming, open source community, or if you are not familiar, people think open source is equal to GitHub. With a growth of GitHub, you have all these projects that solve interesting problems. There is no lack of interesting problems that have to be solved. So many programming languages still have so many libraries yet to be written, so many frameworks yet to be worked upon. You don't have to necessarily start working on new, unique, original problems. It could be just a skill issue. Hey, I'm not good enough yet. I just know how to program in one particular language, Python or JavaScript or something, but I'm not good enough to start writing code in other languages or get into library frameworks. But that does not mean there are no interesting problems, right? There are still a lot of interesting problems out there with code with excellent starting points. You don't have to be the one starting on those. And there are extraordinary mentor figures in these open source projects, either as individuals or as collective organizations. So if you make the claim that there are no interesting problems, I will disagree with you. With the rise of all these open source software, definitely there are so many interesting problems and projects out there. But what happens? We start bringing our ego in. Hey, I should be the one coming up with solutions to these interesting problems. Working under someone else, working along with someone else is beneath me. We fall into this trap, and nothing can save you from this trap. You should be willing to learn. You should be willing to understand that still you're not good enough. You still have skill issues. You need to do a lot more to reach the level that you want to be. So you need to swallow your ego and start working on open source projects. So this interesting problems, so in addition to having a day job, this is very subjective. I have some time outside my day job. I enjoy programming in general. My hobbies sort of are around programming, reading about technology, reading about startups and all those things. So I do understand that not everyone you might have a real world responsibilities, you might have other interests that are not to do with software. But again, it's a choice that you're making. So if you're just saying that there is lack of interesting problems in your day job, you can always look for interesting problems in open source work. And who knows, these interesting problems, when you take it up and do, when you have this, when you're more motivated in these projects, maybe you might switch your day job into picking up a job where you do work on these interesting problems. You acquire the skills that you need and you switch your job. So I believe I have addressed the interesting problems part. The second thing is structure. While I do acknowledge that there is lack of structure in software in general or your workplace in particular, a lot of us have information out there. There are excellent streamers, excellent YouTube content creators on programming that they offer content, but it's sometimes overwhelming. I do not know which person to follow. Someone who I am following, I have surpassed them in terms of skill. I now want to find the next person talking about this next technology. Where do I find them? YouTube search is not good enough. Google is not good enough in finding this. This structure, I do acknowledge. We do always like a helping hand in guiding us. Yeah, it's easier to be led rather than stumble in the dark on our own. And stumbling in the dark, I did mention earlier about people taking the long winded route and how you develop mental strength. That is where I believe someone like me, it is one of my responsibilities, I feel, to add more to the structure. I believe there are other streamers, excellent streamers that I learn a lot from, but I want to do my part in bringing structure. My entire set of videos that I'm preparing for the foreseeable future is to provide the structure. That's why I'm starting from the beginning. I'm starting from what you need to know from school, then college, and then outside in the real world. So I do acknowledge that there is lack of structure out there, but in terms of career path, in terms of projects to work on, in terms of new technologies to acquire, but I would like to help in my part in providing the structure. So I cannot guarantee, but I will make it easier for you if you watch my videos or follow my stream or generally discuss with me in terms of structured thinking. I have taken something of a long-winded path myself, so I know what are all the mistakes to avoid. You can learn from my mistakes and other people's mistakes and then have a structure for yourself. The next 2 points, I will place them somewhere over here. Remember, in survivorship bias or in the Stanford experiment even, there is this concept of delayed gratification. A lot of times people, we start overthinking. Hey, if you offer me a solution, is that a silver bullet? Is that going to solve every problem in my life? When you have a hammer, all you see are nails, right? So we start thinking, hey, if I learn coding or if I take an approach, will I start getting higher salary? Most developers, I believe their first question is, will this kind of thinking lead to better salary? My answer is almost always yes, but you need to practice delayed gratification. If you just focus on interesting problems and structure and do the right things, after considerable period of time, you will have increased remuneration and recognition. I cannot promise jobs for you, But I'm saying historically, those who have succeeded, they focus on only these two. They have a plan, they have a process, they work on interesting problems, they wait for the process to yield itself. Say, for example, one of the celebrities that I look up to is Dhoni. One of the uh, excellent aspects for those who do not follow cricket, MS Dhoni is one of the most famous cricketers from India. He plays the league in Indian Premier League in cricket and all those things. He has a lot of emphasis on process. For someone growing up as a youngster, I sort of feel he was an influential figure when watching his interviews and other things. His emphasis on process leading to success is something that got deeply instilled in me. So that is where I believe you practice delayed gratification. You just wait for 3 months, you just wait for 6 months for results to come. Or you maybe have to even wait for a year if you have skill issues or if you have something else going on in life. But you can definitely start seeing improvements in your life in terms of remuneration and recognition as well. By wanting instant gratification, by wanting quick results, hey, I worked on this project, I want a higher paying job. When we get into this kind of thinking, this kind of problem solving, this kind of mode, which is where our expectations and reality gets mismatched, we give up, we drop off. We start looking for alternative career paths. If you are confident that you can practice delayed gratification, as long as you focus on interesting problems and having a structure in place, some process in place, you don't have to have a very rigid process. A vague enough process is fine. You will almost always, you're just increasing the chances of your success, to put it bluntly. I'm not guaranteeing anything, but someone who is constantly learning will always be offered a promotion, will always find a better job, will always succeed in interviews. But someone who's not learning, oh, I have the skill, I need to be paid for it, will not find the right job, according to me. So that is where I believe practicing delayed gratification, it is the ratio of input to output. A lot of times this is something that I used to do a lot. I have always felt the first time I do something, it has to succeed. The ratio of how much input I put and the value I get, output that I get, should be 1:1. But in reality, it could be 10:1, 100:1 even. Say, for example, let us forget coding. How to do live streaming, how to be at least comfortable enough to be in front of camera, share my screen and all those things is something that I have struggled. I used to be a horrible streamer. I think I'm less than horrible right now. I'm slowly getting better. But to set up the current mindset of when I wanted to start streaming was about a month ago. Every day I've been telling myself today is the day I'll start streaming. And it is like 1 month of input effort to output today, whatever I'm doing. I wanted to get familiar with my tool, I wanted to get familiar with my setup, I wanted to get familiar with how I'm streaming, all these other things, because I am trying to have a high bar. This is where I will move on to the next point. So to summarize, to get into programming, I'll just switch some context over here. Now, so to have a successful career in programming, what is the word that we can come up with? So I would like to come up with the right word for this. I'm not able to let me call it technical fulfillment, or let me just call it fulfillment. Hey, I'm happy with my job. I don't know what the spelling of fulfillment is. Let me just clarify. Okay, is that the right spelling? Okay, that's the right spelling. So when you want fulfillment in your career and from a coding point of view, what is it that you need? Or I can even call it success. Oh, let me just continue to call it fulfillment. A lot of times we just think it is just one thing. That one thing being technical skills. The truth could not be any farther away from this. Technical skills alone will not guarantee your fulfillment. One second now, let me just. So for fulfillment, let us actually translate it to something more tangible, right? When we all work at have a day job, when we work at a workplace, let me actually call it business success. For you to feel successful, your business has to succeed. For you to have your appraisal done, your business should be performing well. Um, for you to be recognized, your business should succeed. So not only within your org, outside your organization also you're considered. Technology is a very small aspect. Your role, I'm not talking about marketing, sales and all those things. How can you contribute to uh, business success from a technology point of view with just technical skills? Is this getting you? Ungroup. Okay. I believe. What am I doing? Okay, which is this rectangle? Just group these together. Excellent. Now I believe there is a gap here. It is not technical skills that lead to business success. I'll tell what the gap is. I'm using full business success as a more tangible example for fulfillment. Do I have enough space? I don't. So let me just move this here as well. I'm still struggling with this. What am I doing? One second. So, for you to have constant success over here, you should become good, you should be excellent in communicating or advertising your skills. So, communication, I believe, is more important than technical skills. A lot of us developers, we just focus on technical skills alone. We don't communicate. You might have successfully solved a problem, but if you cannot communicate to business that it was a very hard problem and you alone could have solved it, then business is not going to have a high opinion of you. It's just, I don't understand what you're doing. Oh, you continue whatever you're doing. They are going to be very opaque. They are not going to look into the effort involved or your thinking involved. They don't have the bandwidth. They have their own responsibilities to do so. So it is up to you to advertise yourself, communicate, and make business feel that it is worth it to assign you on this problem or to have you hired or to give you a promotion. Only then you can go and articulate during your appraisal phase why you deserve that promotion in the first place. But again, these two are not the skills that are needed. You also need business understanding or business knowledge or however you want to phrase it. Now, hey, I'm building this module, I'm building this feature, I'm doing an excellent job, but if you fail to understand where it fits in the larger scheme of things, then you do not stand any chance of growth. Where was my previous slide? If you want remuneration, recognition, interesting problems and all those things, unless you have technical skills, communication and business understanding, I don't think you will have forward progress in your career. You will just be stuck wherever you want. Now, how to develop this? I believe, without getting into like too many details, let me just delete this because I don't have space. Let me just move this up here. Now, I am of the belief, I am coming from more of the business world, startup world, all the things. I am not coming from academia, which is why I am focusing on business. If I want better salary, I want my business should perform better. If I want recognition, my business should grow. I'll explain that. So not only will I get good at technical skills, I'll communicate what I'm doing. When I say communication, it is not English, it is not necessarily grammar. It is about, can you convince a non-programmer what you are doing? Can you explain problems? Can you explain things very quickly and still have impact while you are explaining? No one wants to get into details of how you solve something. Those implementation details are a waste of time for non-programmers. They don't have the priority. So can you communicate effectively to non-programmers, to your top management, to your product manager, to the marketing team, to the sales team, on what you are building? Can you communicate that you have understood? Communication is not just one way of what you are building. Are you able to understand? All these play a major role, which is where I think getting good at English sort of helps at communication. Remember my earlier point of knowing the language. Again, this is where your thinking is influenced by your language. It is not just your thinking, your communication is also impacted by your language. This is why I feel if at all you need to get good at something, it is not, oh, I get good at Python, I get good at JavaScript. It is first, please spend a lot of time improving your communication skills if you want quick results. If you are not comfortable practicing delayed gratification, it's completely fine to go join a course, learn somewhere, and figure out how to get good at communication. So a plug over here. Hi Sunil, I'm not sure if I understood what it means by content. Is there an issue with the stream or something like that? I'm not sure if I fully understand if there is a concern. This is the first time I'm streaming in years now, so please do let me know. It will be of tremendous help if I'm not doing something correctly as how I intended to. So that's why communication, I believe, plays a much more important role. So when you talk about office politics, this is something that happens. When you join, you are not the only developer who joins. There are peers, there are seniors, there are juniors who join, and different people have different progression in terms of career. One person might get promoted even after working so hard. You could be skipped for promotion, while someone junior to you might get promoted or a higher salary or whatever it is. I'm not getting into technical details. If the negative way of thinking is, hey, he's playing politics, hey, I'm not able to do politics. Maybe the other person is just able to communicate what value that they are offering to business in terms of coding or features or just being there. A lot of times I feel the value that I bring to my organizations is not necessarily building new features, but is just being there as a person of expertise and handling questions and clarifying doubts. That gives enormous confidence for other developers to move forward quickly. You might just be the person who has worked with the technology before. For a project, you might not even be hands-on. So you could just be that where you could just play your communication skills to your advantage and not get into programming into a particular project. A lot of people end up thinking it's just your technical skills, your code quality, all those things that leads to business success. Unfortunately, it is not true. This disillusionment, while you're at school, while you're at college, people don't think like this, but when you get into the outside world industry, when you work at companies, this is the harsh reality, which is where the third point, do you understand business? Oh yes, a word similar to fulfillment, yes, being contentment, excellent. So let me actually put it out there. So being content / fulfillment. Thank you, Sonal. Yeah, so this is where I feel I'll take one step back. Some people debate this. I have a lot of debates with a lot of my friends, peers and others. Should we always keep asking for more salary or more success or more fulfillment? I strongly believe yes. One of the Stanford experiment that I covered in the beginning is the delayed gratification, right? If more you are capable of practicing delayed gratification, it increases the chance of your success. Second thing I believe is how ambitious are you? If you are not ambitious, success will not come and fall in your lap. So it is good to be ambitious, but there is a healthy amount of ambition that you need to practice. If you are overly ambitious, if there is a mismatch of your ambition and your skills, if you think you are extremely qualified while you are not, there is an effect for this called Dunning-Kruger effect or something like that. I don't know how to pronounce it. So Dunning-Kruger effect, as we have been discussing biases and all, is a cognitive bias in which people with limited competence in a particular domain overestimate their abilities. So you think you are extremely good, but in real world you might not be. So that is where having an ambition, hey, I will become good. I am hungry, I don't know enough. I will constantly improve myself and becoming better, I generally feel is good. But sometimes people think being overly ambitious, this mismatch can also lead to frustration. I think it is up to each one of ourselves to manage our emotions. My simple thought process is, if you understand that sometimes things take time and sometimes you have to put 100x the input to get 1x output, that is how reality is, then you are walking in the right frame of mind. If you walk in with different frame of mind that everything you touch should lead to success, then when in the real world it does not happen, it can be very defeating. It is not, majority of the times it is not even in your hands. It could be just outside factors. It could be the macroeconomic industry. It could be your boss not listening to you, your boss having personal problems, your business not doing well, so many other reasons. So, if you always quit jobs, switch jobs, whenever such a thing happens, then you are not developing your delayed gratification mental strength. You just need to keep acquiring different skills at different stages of life. Now, all of these are slightly boring. How do I become better at communication? How do I develop business understanding? You might not have thought of it. So they are very interesting to me personally. But how do you get good at this? How do you develop interest in all these things if it is not something that you have done all along? What if just becoming better in terms of technical skills itself consumes a lot of time and energy, and getting better at communication and business understanding is not possible? One very minor point, self-plug is, hey, I will be guiding, I will be talking about all these points and all, but I don't know my limitations. An approach that I have, this is something that a lot of people talk about, the hacker culture wiki entry that I just showed a few minutes ago. Someone whom I follow, the Primeagen, he talks about this. Different developers at different points of time talk about having fun. If you have fun doing all of this, if you are curious, learning, acquiring new information, if you have fun, then things will just get easier and better. You will be able to make progress over a longer period of time. So fun is very subjective. For someone like me, I thought during college, I had computer science from my 6th standard to 10th standard. But due to different reasons, I took up biology in my 11th and 12th. For those who are not familiar, Indian schooling system has kindergarten of 3 years. Then we have 1st standard to 12th standard instead of high school, senior school. I am not familiar with American school system or Western school system. We just have 1 to 12 directly. So in our 11th and 12th, we are forced to choose electives of choices, where computer science is one of the electives. They teach you C programming. I did not take that up. I had biology, but still I had some basic understanding of programming, and I took up computer science in college because I like programming. That is what I wanted to do. I thought I knew what I was signing up for, and thankfully luck was in my on my side, and I have been enjoying computer science programming. That decision thankfully has been successful for me. I would not attribute it to my wisdom or anything. I don't think I had any knowledge back then. I didn't have peers, but generally I enjoyed the process. I will say, yes, having fun was one aspect, but my way of having fun in college is very different from way of having fun right now post college. I felt those 3 years or 4 years, from first year to fourth year or second year to fourth year, when we are actually doing computer science, I should change the definition of having fun. I am someone who has been playing video games right since my childhood. My friends and my peers used to tease me saying, hey Anirudh, all you know in computers seems to be just playing games. A computer can be used for so many purposes. Are you even aware of it? My brother used to pull my leg. Yeah, are you even aware that you can do more things in a computer? All you seem to do is go to switch on the computer whenever it's available. We used to have a shared system for our entire family. I think the first time I became familiar with the computer was my uncle when he got a computer for my grandparents. Then maybe in my 5th standard or somewhere when I had a computer at home. My father got a computer. I got a laptop in my 2nd or 3rd year in my college. So I've been on a shared system and all those things. The only thing that I used to do was start the game, play the game, then exit the game. I never used to explore other things. I was vaguely familiar with all the things, but they never had the curiosity. So for someone who has grown up only on video games, I realized that they are going to be a distraction for me. I am completely incapable. I felt that I was completely incapable of handling video games and learning computer science while at college. So I completely said, I'm going to sacrifice. I'm going to be hands off on video games. Here and there, after exams got over, 1 or 2 days is when I spent time playing video games. But after that, I used to get back learning. I used to convince myself that learning computer science was more fun than video games. But I also knew that that's not true. That is a way of brainwashing myself, right? So when I did the step out into adult life, my way of having fun right now is just striking balance. 50% of your time just keep learning, 50% vaguely. And again, I don't use a time tracker. I feel those make me feel more stressed more than anything. I just try to strike a balance. It might not even be, oh, I play 10 hours of video games in a week or 10 hours of computer science. It could be that I just spend the next 4 or 5 months learning computer science and next 4 or 5 months playing video games. I just leave it up to my mood and all those other things. I don't try to be too rigid about it to cause stress for myself. But I always feel I am having fun. That I believe is such a fundamental bedrock to be good at all other things. So my way is somehow I always convince myself, hey, if I've spent a lot of time doing productive stuff and I just want to while away time, sometimes I just take the entire Saturday off. From morning to evening, all I just do is play games. That just rejuvenates me for an entire month sometimes. So you figure out what will make you have fun, but I want you to be conscious of, are you having fun? What will make this fun? And work on doing it. Sometimes, like as I told, for example, I am trying to enjoy streaming, but I know I come across as a very serious person. But internally, I'm enjoying streaming. I enjoy sharing my thoughts, talking about all of this. I feel more you teach, more you internalize those thoughts and you become better at them and all those things. But that fun might not show up outside. My face could be all serious. I might not break into a smile forever. I could be going on and on. You might be like, hey, Anirudh is going to have a heart attack, or you might just explode at any minute. But I feel I'm just having fun. So it is up to you internally what you feel. Whether externally it is considered to be a fun activity or not, I will say that please do not be swayed. But sometimes there is something called too much of fun, where you spend enormous amount of time not doing it. It's, I would like say, it is more of consumption. You play video games, you watch social media, you watch movies and all those things. It could be associated with computer science. You might be watching some documentaries and all those things. But if you just keep consuming, you will feel miserable. This has been written a lot, and from first-hand perspective also, I feel this. You cannot just be having fun all the time. You need to be also building things. Go out there, do something, build something, even if it is terrible. I feel only when you put your knowledge into practice, you gain that experience, and only that experience you will remember. It's very hard to remember things from knowledge. So I'll keep talking about this a lot. So let me just pull up a diagram for this. Where is it? 1 second. So for those who are watching on the live stream, I believe this is being recorded. So if you find it boring, you can always watch the video on all these platforms later. Now let me get to what I was trying to say. I believe there is level 1 knowledge on several things. This is reading books, watching videos, courses, tutorials and all those things. Sometimes to become an expert, the real level is multiple levels higher. It's not just applying this. You might need to build a project, you might need to work on that project for an extended period of time for you to have any amount of competence. Forget expertise. To even be competent, you will have to do things at several stages to reach true competence, true internalization of the things that you have learned. So I used to think the best way to learn, say for example any book, not even just programming book, is I have to understand every paragraph. That's a nice way to learn. So for example, it's a digital book. I used to, whenever I encounter words that I don't understand, I'll pause there, open Google, try to find the meaning of that word and move on. But what ended up happening was, I could not get past the first chapter in so many of those books. These are not fiction books, non-fiction, technical computer science books. I completely changed my approach. What I do nowadays is, any book that I want to learn, I do at least 3 iterations. 3 is my number. First time I read a book, I just get to become familiar with the jargons in the book. It is also to do with, hey, does this book address all these problems or not address all these problems? So I get a full lay of the land. Hey, if I truly understand this book, I will get this skill. I might not get completely another different set of skills at all. Say for example, I'm reading about a web framework called Phoenix. The first time I have read that book multiple times. The first time I went through that book, what I felt was when I went through the examples, hey, this is not going to teach you how to build games. It is not going to teach you how to build a social network. This is not going to teach you how to become better at algorithms or data structures. More than what is there in the book, what is not there in the book is what I infer the first time I go through the book. Okay, the next time I go through the book, these are all the things I set expectations to myself. The second time I read a book is when lot of things that I missed the first time, I truly begin to understand. My knowledge formation happens only at level 2. Level 1, I'm completely unable to internalize. I've done this over the last 2 decades. I have recognized that every time I do it in one iteration, I don't understand. Only in the second iteration, I start to, even then it's not perfect understanding, I begin to understand several concepts, start connecting pieces in my head. Oh, whatever they are mentioning over here in chapter 1 is what they are going to talk about in chapter 6 or something like that. Vaguely, I begin to form these associations. That is where information in the book or data in the book starts becoming knowledge in my head in second iteration. Third iteration, I feel, is where you perfect this knowledge, you feel more confident, or if I want to memorize a concept, I usually do it 3 times or more. This applies to a lot of things in life. I could watch a tutorial video, some Hello World, some framework, follow through. I remember this example from college. I believe most people coming out of college nowadays, or in the last few years, even the pandemic batch and all those things, are much smarter than how I used to be. I was in a decent college and all those things. I got through into that college, but I remember one of the first projects that I worked on as an intern for a company. They asked me to get familiar with a PHP framework called CodeIgniter. I would have gone through some 30 videos for about at least 100 hours. Still, I never understood what it was. I could never understand what MVC was, what patterns were, how to use them, because all I was doing was watching the videos. I was never writing code alongside. I was never thinking how do I modify the code to get the output that I want. Again, repetitively watching the videos gave me a big fat 0 in the terms of knowledge. That internship was, so they said, okay, if you are not able to understand this, we'll give you a project later. Later I got a project in Rails. Again, I made the same mistake. I did not fully understand Ruby and Rails. I could just follow something. They told, okay, can you demonstrate not using the scaffolding part of Rails and still create it on your own? I could not. Just the book or tutorial or reference that I had spoke about scaffolding. I could not even process how do you write the same code without using these scaffolding tools or whatever. That is because I was not writing full-fledged applications myself using that web framework. Again, whether it is fair for a college student in their second year, third year to do all of this when tutorials were even more lacking back then is something to be debated upon. But I felt what mistake I was doing was just reading from books. So even if you are watching these videos, my other videos, unless you start hands-on programming and are ready to put 100 hours worth of effort for 1 hour worth of value, it is generally difficult to acquire new skills. I'll talk about all those things, what it comes to. This is where I believe lot of times you have to go back and acquire the same knowledge again and again. You will suddenly become an expert. You will not know when. There is this quote on, I spent 10 years to become an overnight success. What that means is what people see outside as an overnight success, you would have spent a decade upon building those skills. So when I say, for example, you acquire a new piece of knowledge, say you want to become a Rust programmer, just going through Rust documentation, you might fully understand what it is. But unless you build a tool or multiple tools in Rust, still you would not have internalized a lot of those concepts. So the same we are going to do in Elixir. A lot of it I am setting up context because I want you to be in the right frame of mind before we go into Elixir. Today, like over the next few days and all, we will just be covering only level 1. Only by doing hands-on projects on these live streams where I walk through my projects, open source projects, different kinds of projects, your knowledge, where I will encourage that if these videos are available offline, you code along of those offline videos or while live streaming also, or you figure out offline to how to get familiar with these projects. The main purpose of these streams are to make you familiar with the mistakes that I do so that you don't make the mistakes. So that way you save time, but you can't skip the process of doing, of executing. In learning, you might be faster by watching to my stream or any other videos out there, but there's no shortcut to hard work. You have to put in that hard work, you have to get hands-on practice. If you find a day job that gives you that practice in your daytime job, your 9 to 5 itself might be good enough practice for you. So that is a trick that I will suggest. If you are looking for career opportunities, can you find opportunities where you want to grow in a skill? So you'll automatically grow over 6 months, 1 year, because you have to keep delivering in your day job. Now going back, let's have fun, build things. Build things is where I feel you have to start putting things into action. Now what this actually leads to, 1 second, what am I, oh again this grouping, I think I'm doing something incorrectly. I should get familiar with this. Did I just draw a border around this? What is going on? Okay, delete. No, this is a text field. Why is it not getting deleted? Okay. Oh, my cursor is a text. Why is it not switching? Okay. Over here, this is not partial selection. This full selection only gives you full selection. This is my text. Oops. What is this outer group? Just a minute. Ungroup, Command Shift G. Excellent. Now I have this at least. Huh. Now, when you have fun and when you start building things, that is where the secret of everything. What did I just copied the text? Rather than doing this, I'll just copy from there. The secret sauce of all successful people who enjoy their job is internal drive. How can you motivate yourself? How do you not wait for societal validation, for your boss to validate you, for your job to validate, for you to build interesting projects, GitHub stars, all these things. If you stop seeking, if you just have fun, and when you build the things, it leads to internal drive. You get better, you become better in technical skills. Now communication and business understanding, it's not very obvious. For someone like me, I thought I used to be an excellent communicator. I just realized I'm a chatterbox. I just can keep talking endlessly without making sense. That is not the same as communication. So for someone like me, I went and joined a peer group called Toastmasters. It's a complete non-profit. There are so many clubs all over the world. You can go join a Toastmasters club to improve your communication skills. There's a process that they follow, both in terms of listening and speaking. You just become better than who you are. Whether you will become the world's best speaker, that's not guaranteed, but it's constant improvement. So that way you improve your communication skills. For business understanding, I read a lot of business books, business blog posts, watch a lot of business related YouTube videos. That's how I grow. So, but again, I have fun while doing all of this. I try to build something related to it. For when I say build things, it's execute. So in communication, I actually go to these meetings. I actually participate in contests. I actually take up responsibilities. That is where you don't consume. This part is consumption. This part is creation. You actually create something of value. That is when the internal drive feedback loop gets going and you will make progress forward. So one important point that I'd like to mention is, a lot of times people regret their past. Oh, the answer is super obvious. It is nothing hard at all. It's very simple. I just do all of this, but I should have been doing it all along. That trap is what people get into. I am going to be 34 in 10 days. can keep regretting wasting my 20s, not making much progress, all those things, or I could improve from here on. We can focus on the present, being optimistic about the future. Regretting about the past and feeling negative about it, I don't think helps at all. Now we are done with enough of context setting, having the right attitude, philosophy, and all those things. Now, the next point that I would like to discuss is a good first language. This is something a lot of people enjoy. They want to, the most common question is, hey, I want to get into programming, or I'm already in programming. Which language should I learn? Now, I believe I was taught C. I don't think C is a good first programming language. People confuse C knowledge with C++ knowledge. C has a lot of advanced topics. C is an excellent language for intermediate to advanced programmers. But I don't think C is a good language. So I believe a lot of schools and colleges have stopped teaching C, which is good according to me. What am I doing? Why is my stroke line pen take? What is my stroke line? 1 second. Show context toolbar. Is it because it's a new docker? Also, what is the color of my stroke? I want it to be white. Excellent. So I don't think C is a good first language. I don't know what I'm doing here. This is my way of striking through. Now, what I believe are good choices by everyone in academia, schools, colleges, boot camps is Python or JavaScript. I think they are excellent languages to teach basics of programming. You can become an advanced JavaScript developer, Python developer and all. But one issue that I have with Python and JavaScript is when you think of growth in terms of how you approach problems, skill, let us call this y-axis as skill. Can I ungroup this? Yeah. So your skill or expertise or capabilities plateau after some point of time. This is time according to me. When you learn these two languages, very rarely do programmers just get really good at these languages alone over a period of time. At some point of time, growth literally stops because you are not familiar with other ways of approaching writing code. I quoted one language quote, right? The same thing with programming languages. I believe these teach you basics of if conditions, for loops, while loops, switch statements, methods, functions, parameters, basics of getting familiar with libraries, how do you use these libraries, function calls, all those things. But at some point of time, developers start building sophisticated projects only with this knowledge. I believe a language should push you, it should push you to grow. You should always be familiar with several languages, and you should have a primary language. The primary language is where you are really rock solid, you know what you are doing, you are extremely good at it. That language should give you skill growth like this, where initially it is very difficult to do things, where a language like Python or JavaScript gives you much more better benefit. But this language, at some point of time, when you cross this threshold, you suddenly start solving problems much faster, much better, without lesser bugs, with lesser code, with better tools, better way of thinking, better documentation, all aspects better. This is where language, ecosystem, framework, all those things, picking the right tool is extremely important. So what am I proposing? My proposal is, if you are not familiar with computer science at all, and if you are boot camp or your teacher or someone else, when you are not familiar with programming languages at all, go ahead and learn in Python or JavaScript. But seek out several different languages, have this breadth-wise knowledge on languages, figure out one where it makes sense to you, go very deep in it. It could be Zig, Rust, OCaml, all these modern languages. It could be traditional languages. It could be one of these languages, Python themselves. I'm not denying that these languages are not capable. They are all general purpose languages. You can build websites, you can build mobile apps, anything. I'm not getting into details of what you can do with all these languages. We'll cover that over a period of time. But this is the approach that you should be taking after you get familiar with basics of programming. You should search for programming languages, then get good at one language that forces you to learn, think better. Say for example, what is the downside of, I've already told Python and JavaScript, what are the downsides? You don't have to keep learning, you can still keep churning out content, but the content will be of mediocre quality. When I say content, code. But when you learn these other frameworks, you can churn out better quality code. You can think smarter, better, and all those things. Also, in addition to just the language syntax itself, I believe there is a flaw when there is a downside when the language becomes too popular. You do not have this guiding hand. I spoke about structure, right? Hey, what project do I start on in this language? Whom should I follow? There are so many people out there, so many projects out there. I'm spoiled for choices. I am having paralysis by analysis. I'm overthinking. So when such a thing happens, so like when you have too broad of a community, lack of community leaders who set vision for it, where it's not very opinionated, you can do whatever you want, and you lack this guiding hand, it is very difficult. So if you cannot answer the question, what are the most important projects that I can work on and have significant impact, then you are in the wrong ecosystem. Like you need to be able to find the language where this is guaranteed. So my one line suggestion is pick a programming language where becoming an expert actually is worth the effort. It should be worth the effort. You are spending so much time when the skill should actually lead to equivalent value. If value is not catching up with skill, then you are spending your energy in the wrong. I could be learning esoteric languages which are just hard to master, and I can get really good at them, but if you're not able to apply it in real world use, I don't think it's of value. So pick a programming language where becoming an expert is actually worth the effort that you are putting in. So that sort of, I will say, a good strong language which makes you think writing code differently, enables you to move faster, and overall just write better code. That is where I would like to not talk about Python, not talk about JavaScript, the core of the stream today, which is Elixir. Elixir as a programming language. Now, before we go in through the Wikipedia, before we go through the official homepage of Elixir and other things, I'd like to just quickly summarize what Elixir is. I believe Elixir is very powerful in the way you think, but it also has a very easy learning curve. You can start writing some code quickly. To write more sophisticated code also, it is not very that hard. It's not like unfamiliar syntax like Lisp style of programming, Clojure, that kind of syntax where it's just plain horrible to read. I don't like that kind of extra parenthesis as a person who's transitioning from first programming language to finding their primary programming language. I don't think. Also, extraordinary community in Elixir. Repeatedly people have said, one, everyone is very nice. I'll talk about why that is true. Second thing is fantastic projects, very high quality projects that are built by the core team within the Elixir community that you can attach along to, you can join along, improve, have real world impact, where you are producing high quality work with not that much effort. I'm not saying hard work is not needed, you need to put in the hard work, but for the same amount of hard work in other communities you might not have much of an impact. Rust, for example, is a fantastic community, but there are a lot of already so many projects out there, you might not be able to have much of an impact. But in Elixir you can, in maybe OCaml also you can have, because the community is still not that big yet. Now, what is the downside? If Elixir is that good, I've been programming in Elixir for 5 years and all, I will simply say lack of exposure. Not many people are familiar with Elixir. That by itself is not a major issue. It is lack of jobs because of that. because so many non-developers, hiring managers, CEOs, all those people are not familiar with Elixir, they will not hire for Elixir language developers. So if you learn the skill, is a job guaranteed today? I don't think so. There are definitely places out there that hire Elixir, but not as common as say JavaScript or any other popular language in job boards. Now this, before we get into the language itself, I would like to again draw a diagram for this. Now let me take a step back. For a business success, this is not as an individual how you see as a business. For a business to succeed overall, I believe there are two fundamental principles. This, a lot of people have spoken about this. There is a book by Peter Thiel called 0 to 1 where he talks about this. This is common knowledge. One is technology. When we say technology, it is not necessarily code or software, it could be anything, but it is the underlying core of your business, what value you are offering. The other thing is distribution, which means how many people are you able to reach through marketing, sales and all those things. For a business to succeed, usually successful business, for a business to succeed, almost anyone who with experience, including my boss, it is distribution that outweighs technology. You can build a fancy product, but if there are very few users, unless you charge a bomb for it or something like that, if there are very few users, even if the product is fantastic, your business is not going to succeed. But you just build a very mediocre quality product, and again, it's not software, anything else. But if you are able to reach a large number of people and solve the problem for them, then your business will succeed. So there is this technology angle to it, everything in business, and there is this distribution. Can you reach your customers? Who is, say for example, I will tell this, I work in the fintech industry, this is a phrase that I keep telling. Banks have very poor UI UX, at least used to, websites and mobile apps. All these fintech companies have extraordinary applications, but banks have tremendous reach. They have so many physical actual locations all over the country, all over the world, but your fintech apps are just on the app store or just on the website. So through sheer volume of distribution, banks will always succeed when compared to fintechs. So technology definitely helps, but it is distribution that outweighs. Now the same thing, if we think of Elixir as a programming language, I will say Elixir's success or Elixir hiring. When I say success, Elixir being considered as a language where jobs are there. So let me call this as Elixir jobs. Over here, the lack of distribution, not many people are already talking about it, is the reason why there are not many Elixir jobs already. It's a chicken and egg problem, catch-22 situation. More people start using Elixir, more jobs will be there. But from a technology point of it, I fundamentally believe that it is in the sweet spot of being the primary language that you have to do, because it solves problems at different layers across the stack. Technology, I have a personal bias, because I write code in Elixir full time. I will give it full marks in terms of technology, but in distribution is where it's lacking. One of the reasons is a lot of these frameworks, technologies in other communities or in many famous communities have a large corporate backing. Say for example, you might be familiar with React. React would not be this popular unless Facebook had pushed it, or Facebook did not push it too hard, but the fact that Facebook is internally working and maintaining React made a huge world of a difference. Say for example, Flutter, Google backing it makes a world of a difference when businesses have to use Flutter as their mobile app technology. A lot of Microsoft technologies and all. So, but when it comes to pure open source, generally it is very difficult. This distribution problem is unless you have celebrity figures or say for example, I know TJ who I follow regularly on live streams and watch his videos. Nowadays, he's been writing Elixir code as well. That leads to more Elixir popularity. Unless influencers and live streamers pick up and talk about the Elixir as a language, I think that Elixir jobs challenge is still there. But what did I talk about in one of my earlier things over here in these diagrams? This interesting problems and structure, fantastic in Elixir. The remunerate, even the recognition thing, I will put it over here in Elixir. If you contribute and do things, you can be a driving force in the Elixir community. You will be regarded as an authority figure for a project, because there are still very interesting projects out there that can be built. I'll walk through the lay of the land very soon. The remuneration job aspect of it is where you have to practice delayed gratification. So this is why I have these diagrams open. With that, let us get into Elixir programming language. I'll just go catch some, have some water and then be back. I'll just keep this open. You can keep browsing through. I'll be back in a minute. So what we'll do is, I have so many tabs open. We'll quickly cover through the tabs, and also I will just showcase the initial these are the Wikipedia articles I want to spend some time going a little deep on, so that we read them together. But I'll also show these tabs on what we are going to cover very quickly. So that way you are not left thinking, oh my god, it's going so much into theory, how do I even apply it, all those things we will not go into. So some context on Elixir was created in 2012 by Joseph Allen. He is Mr. Joseph Allen. I told the Elixir community everyone is very nice, right? I believe that is because the creator of the Elixir language is very nice. He shares a lot of information, works on a lot of open source projects, is a very guiding figure to everyone. I think he sets the tone for the rest of the community. Him and other leaders are all very nice individuals, which makes the working with others, asking questions and getting answers super fun, super relaxing. You don't have to, the bar is not very high. You are not forced to know so many things before you even ask them questions. So Joseph Allen is the creator of Elixir language. He has been working on it since 2012. The latest release is 1.17 with some new features that are landing in terms of types in the language, which we'll cover in I'll talk about types and all those things, but this is just to set some context. So Elixir piggybacks on the success of another language called Erlang. What and how and all we'll tell. Erlang was started in 1986. So one of the famous companies that uses Erlang for their engineering, used to at least use for their internal messaging, was WhatsApp. So Erlang was built for telecommunications and other things. We'll also go through Erlang. A lot of fundamental rock solid engineering has gone into Erlang. Elixir just provides a nicer syntax on top of Erlang. We will also cover some fundamental principles within Erlang so that we learn how to leverage them in Elixir later. I'll also cover some deeper points when we go through Elixir. But before that, this is the homepage of Elixir, elixirlang.org. You can go over here when you search for Elixir language online. This is the web page you stumble upon. They talk about what companies use it, what all features are available. Now I want to quickly cover some interesting projects in the framework, in the community, what you can actually do with Elixir, some personal favorites of mine. Over here there is the getting started. A lot of things are well documented in the Elixir community. This getting started section is where we'll go through over the next few streams. Probably I'll just go freshen up and then start one more stream or something like that, where we walk through all of these. It's impossible to cover it in one single day or one single stream, but the idea is if you go through this getting started, you will not have surprises when you go through code. So I believe this is extremely important. This is something that we'll go deep dive into the language syntax itself. Mix is a tool within the Elixir community. I believe it is somewhat similar to a, what do you say, npm and all. It's a build tool mainly for creating, compiling and testing Elixir projects. It mixes how you don't type Elixir and directly compile a file. You compile a project using Mix. IEX is something, an interactive Elixir terminal. I'm just putting out these jargons out there so that you get familiar when we go through them. You can run commands in a terminal line by line. You can execute Elixir lines of code and get output how it is. Then Phoenix is one of the reasons why I got into Elixir, an excellent web framework. You can build fantastic applications with Phoenix. Chris McCord is the creator of the Phoenix web framework. It scales a lot of problems in other comparative web frameworks are all solved due to Elixir's green threads and all those things. It's low RAM requirements. So because of that, you can scale up tremendously using Phoenix. A lot of improvements over here. This is the documentation of Phoenix. I believe it is generally very difficult to use a language and keep building tools. I believe there are two kinds of programmers. Systems programmers who spend a lot of time into building libraries, thinking about the right kind of data structures. Then there are application programmers who use these libraries or frameworks and tools. I think we'll have to cover both. So when we go deeper into Elixir, we are thinking more of a systems developer point of view. How do I come up with the best practices? How do I think about performance and all those things? When it comes about higher level frameworks like Phoenix, how do I do right things for the web and all those things, we'll cover that. Phoenix internally uses a framework or library by itself called Ecto. Ecto is something like an ORM, an object relational mapping. Yeah, I am filming YouTube videos simultaneously, but you can go ahead and ask the question. I'm not doing it as a continuous, how do you say, I'm not going to edit this video. People have to consume this. SBoy3444, please go ahead and ask your question. You can, if you are okay with the question being handled on the live stream. So Ecto is a database library. You can write more easier syntax Elixir code on top of your database. You don't have to write raw SQL if you are in writing code in Elixir. So all of this documentation that you have seen so far is using a tool called HexDocs. A lot of documentation. You can prepare your own documentation and publish it in Elixir. HexDocs is something where you can find all libraries anyway have their own equivalent HexDocs. Now different libraries nowadays have library plugin managers. You can go fetch libraries that others are building. You don't have to drag and drop like those olden days or pull in source code or other things. You can fetch libraries in the Elixir ecosystem. You can say, for example, here are some topmost libraries. You can find some how often is it being used, when it was last published, other information. But the name of the library and the version is what is more important over here. That is called Hex. HexDocs is how you do the documentation. Hex is the package manager. Then one of the major advantages of using Phoenix as a web framework is a fantastic concept called LiveView. It makes building interactive applications on the web much easier. Okay, I've been trying to learn the code for many years on and off, but I can't grasp concepts at all well. I feel like I'm an imposter. I can't build anything on my own at all without landing in tutorial. I just know very little HTML and CSS. Excellent statement. I used to feel this not for a short period of time, for a very long period of time. In fact, I'll go ahead and admit this on stream. The first job that I had, I didn't even have proper documentation. It was all in C# and all these things. I struggled. I could not make sense head or tail, I could not find tutorials, I could not find sample code. I have been through that difficult. So what I generally believe is there are two kinds of long-term success approaches. One is using what is your what is that called, your forebrain or something. Where it is all to do with logical thinking, where you attach different pieces together, you arrive at a conclusion. The other is the hind part of your brain or something like that. Again, I don't know the exact scientific term. I'm not able to recollect them. This is where practice, repetition, your subconscious, where things become more intuitive, where you progress forward. I believe, okay, someone I believe is following. Thanks, SY. I'm not sure why I'm not getting the notifications in my actual feed where I'm supposed to. I am having live stream issues. So the part I'm trying to communicate is, it is very difficult to logically connect different things, especially when you are on your own. Even if you follow tutorials, you will not be able to internalize. You need to have something called a feedback loop, where you build something, see the changes, and keep building more and more further, where your brain begins to form the association between what you are building versus the outcome. So for a lot of people who don't have programming experience or who have not been thinking logically as programmers, there are usually two kinds of programming people say. Front-end programming, where everything is visual, then back-end programming, where everything is code, you just see data structures as output. I had to start more as a front-end programmer for things to make sense. I started building web applications, mobile applications, even command line tools. I just started building in the output-based manner. Only then you can start making that connection. Any language, any technology, unless you pick up this front end, if you directly jump to back end, say for example you want to build a Rust program application, you want to build a Rust library, very hard to reason about, articulate until you get familiar with other kinds of programming. That is where my emphasis on learning Phoenix as a framework. It's a web application. Yeah, I can always see the results in a browser. When I do changes in my code editor, I can see the results on page. When I click a button, it goes to the next page. I can start tying these threads together, and then instead of thinking of them every time using my forebrain, it becomes so intuitive. Then now I can start forming. I spoke about this higher level thoughts, right? Where is that? So the difficulty is, if you are thinking always in level 1, it can become exhausting and you will forget. Unless you develop this higher order thinking, thinking of things very at a very high level. Yeah, I know where this is, I know where the code is to be, I know I have done it so many times. Through experience, unless you do it, it can be very difficult. That's the hard work angle that I'm trying to say. Not just by following this stream, by following tutorials, by following other streamers, you'll get some amount of exposure. But unless it is, how do I say, in the gym, there are two kinds of approaches. You just straight away put the weights to your maximum limit and start trying to lift and get discouraged, or you just start very small and you do more reps. And generally I believe you build actual muscle strength more by reps rather than the weight or something. Again, I'm not very sure. So this reps is what I'm talking about. More you build these hobby projects, hobby software along with me or something like that, you cannot progress from level 1 to level N kind of thinking. Isn't it better to just start building what you love? Learning happens on its own. Getting a structured knowledge can come later. That's not true. This is where I am trying to say, good first language, Python and JavaScript. A good primary language is Elixir. A lot of times we think with this good first language, we will build thinking on our own. But what we end up doing is we start falling into a lot of traps. One simple trap I will mention is, if you program in Python or JavaScript forever without trying to, and if you are more feature outcome, more, okay, this is something that I really have to draw. 1 second. Again, I'm still not comfortable with the shortcuts. Yeah. Now, I am building a software project. I am having a feature 1. I'm very happy with it. I followed some tutorials. I'm slowly gaining some knowledge. Now what do I start doing? I start building more features. Feature 2 and so on. This I have to represent visually. I have n features in my application. Now this is very much possible using your first programming language like Python or JavaScript. Now what happens is, how do the features interact. What am I doing here? So I am building one screen, going to the next screen. This next screen, I'm interacting with all other. Sorry, I hope you get the picture. Once again, I'll have to go back to the earlier diagram where I have the arrows. Okay, can I just copy paste this arrow? Does it work like that? I'm not familiar with this. Okay, I have some arrow over here. Oops, I can't move on these points. Just give me a minute. What I'm trying to explain is, every feature will have to work along with every other feature. Otherwise, you will have bugs in the requirement level itself. I will change the stroke. Set it as 2. 1 second. I'm surprised that for every diagram I am forced to do this. Yeah. So every feature has to interact with every other feature. Now what if I add, let us call it feature 3. Now so far there are only 3 interactions so far that we have discussed. Not that bad, right? 3 features, 3 kinds of interaction and how these features interact. Now what if I introduce one more feature? Will the resultant output of how these interact just be 4? No, it actually grows exponentially. It is not exponentially, quadratically or something like that. N into n plus 1 by 2. Now, when I am adding one more feature over here, all my existing features, they may not be actually related, but I might have to keep in mind, do these features interact at all? How am I going to be very confident? What if a user jumps from one of these screens into one of the other screens? You see over here, I have added 3 more what's these edges in the graph. Very quickly, if you keep adding more and more features, the connections between them start getting very complicated. When these connections, how are these features represented? They are represented in code. That means your code becomes getting complicated. So every nth feature you add, you have to think of all the n-1 features beforehand, which means every new feature that you have to build, it's growing, but in terms of cognitive effort, in terms of code, how much code you write and all the things. I'm just exaggerating slightly over here. It's not that every feature always affects something else. But then what you end up having is extraordinary code verbosity. You have just thought of each individual feature on their own. You are writing each individual modules on their own. But when bugs start to appear, you do not know where to abstract this, where you have to, how do I write, where am I exactly supposed to fit in this fix? Am I supposed to duplicate my code everywhere? How am I supposed to call this everywhere? Unless you have a language that makes you regularly condense the code. When I say code, also your thoughts. Makes you think in a manner where even though features keep growing exponentially, my thought process or the amount of things that I am supposed to know only grows linearly. We have this graph, right? Where is this graph? Yeah, this is exponential growth. This is not at all sustainable. I can't do this. What I want instead is something like a linear growth in terms of code, cognitive load, effort. I understand that it is growing, but it's not growing too much beyond my capability. That is where some of these languages, I strongly believe Elixir as a language, this is where design patterns and all those other things also come. How do you maintain structure of your code, how you architect your code and other things. You cannot easily intuitively come up with this in terms of simplification of how you write your code, because your language does not provide you a way to think like that. If there is no grammar, if there is no word in that language, how can you think like that? This is how I fundamentally type. You need a language that keeps again and again compressing your thoughts, where rewriting that entire thing is, rewriting might be hard, but the result of that rewrite is always still very small amount of code. Where I disagree. So my process I'm trying to summarize is, there are 2 stages. Once like you get, if you're a non-programmer, you're just getting started with programming, you pick a good enough language, your first language, get familiar with if, for loops, while loops, switch cases, how flow works, things and other things work. At some point you build some hobby applications. You say that yes, I am now a beginner programmer. Now for a beginner programmer to start the journey of beginner programmer to intermediate programmer, I'm going to go through several languages. And here, for example, Elixir is one language that seems to be solving things much quickly. I can build several features, but still the cognitive load that I have on my head is not much. I'm able to still achieve so much output for very little input that I'm doing. This, I believe, when you take the straightforward approach of building extensive application, say for example, this is the entire problem of what traditional JavaScript, vanilla JavaScript that you write on the browser, of how you handle events, input fields, forms, submissions, button clicks and all those things, versus what React actually tries to solve. React and similar frameworks introduce something called as reactive programming, which means I can try observers, listeners and all those things. When one thing changes, I write a rule, more like a declarative rule, where things change automatically. If I have to hand code, you will end up with this exponential problem that I am talking about. Every input field changing another input field, and chain transitive set of things writing in vanilla JavaScript becomes a nightmare. That is why React and other frameworks, according to me, took over the front end. You can write complicated applications in a simple enough manner. It's easier to reason about all these things. A lot of the code disappears when I write this reactive way of doing things in a declarative way, where internally the library does the events, listening to events when a parent changes, child changes, all the things, childs pass their listener to their parents, all those are taken care of. That is what the framework provides, so that as a developer I have good syntax. So it is the thank you Joe Ka the gamer for following. This is where I am trying to say, when you can keep writing vanilla JavaScript on the browser forever and be miserable, or learn a framework like React. I'm not recommending React, but generally becoming more exposed to frameworks where you can get the same output, where this graph is true, where more and more complicated features at some point of time I can manage. It's manageable. When you write vanilla JavaScript, it becomes exponentially harder over a period of time, because the language does not provide you an ability to get rid of code. Getting rid of code makes you getting rid of unwanted thoughts. So the state of flow is something we all talk about as developers. Once you enter a state of flow, everything, all thoughts occur to you naturally. You just keep making endless progress. I told about the ratio of input to output, right? I told that you have to be ready for 100x input for 1x output. When you enter the state of flow, 1x input will give you 1x output. That means you are mastering that framework, mastering that tool, mastering that library. My point is, how much ever you master JavaScript on the browser, you will never reach that flow stage. You will end up only with more bugs when you keep building more and more complicated UI applications, because JavaScript on the front end before these frameworks was not attempting to solve the problem of complexity on the front end. But then people started building fancier applications, which is why these new frameworks were actually born, where they take care of so many things under the hood. By just this reactive programming itself, where things automatically take care of each other, I stop writing lot of that code around it. I can reason about things at a higher level. That is what, where is my, higher level. That is what enables me to move faster. You spend 3 months doing a vanilla JavaScript application, a fancy application, versus you take a month to learn React. Within 1.5 months or 2 months, in the next 1 month, you have learnt a technology that will enable forever in your career. That is why people spend time learning, which is why I also kept emphasizing this building things over here. You learn and keep applying them. You use these higher order learnings, frameworks, tools, libraries that other developers build for you. You can keep moving much faster. So how do you stay focused on the screen and do focus learning on what really matters? So this is where I believe, I am of the belief that internal motivation does not last. When I say internal motivation, what we normally think of is, oh, I'm so pumped up, I have so much energy, I'm going to do this today. Within 3 hours, when you're hungry, when you're tired again, you are going to feel normal or below normal all over again. That doesn't last forever. There is this YouTuber called Dr. K. I like some of his videos. I used to watch it long ago. I'm not watching. He defines motivation as having the same thought over a longer period of time. Daily you wake up. Say for example, I remarked this earlier. I've been wanting to do streaming for nearly a month now. Every day I think, oh, today is the day I'm going to stream. But something comes up, I find some excuses and do not do it. But just having the thought without giving up made me start on it today. So each one of us are fighting our own mental battles. Oh, some excuses, life is not going right, someone we know is having issues, we have to be there to help them, or we are ourselves having issues, life happens. So how do you move on is to just believe that I need to keep moving forward without attaching any emotion. You don't attach a positive emotion or a negative emotion to that thought. That is what I believe. So I don't go straight into building first. This is where I sort of feel embarrassed that I used to program applications and all those things from college. And I've been in the industry for 12 years. I feel embarrassed that it has taken me such a long amount of time to produce the output that I want. That is very, I did have that imposter syndrome for a very long period of time, but growth does not happen continuously. It happened in spurts. I have been observing how that growth happens and trying to ensure that kind of environment is what I have. Where the final point that I mentioned this earlier, I would like to mention it again. How can you ensure that daily you are in that frame of mind, you are not thinking negatively about it or positively about it, you're approaching that frame of mind neutrally. For me, it has been a day job. I've been trying to somehow associate technology with the next job or something like that. I find I'm not working in the first place that I ever joined. So when my day job forces me to build things, I have a deadline, I have an update to give, I push myself to learn. Instead of just generally improving for my own individual sake, hey, I have a responsibility now. I am now accountable for the future I am building. I have a deadline. So I have to finish this at that point of time. So it is more like picking up weights and trying very hard at home versus just turning up at the gym. You might just do things normally, you might just do basic exercises, you might just lift weights smaller and smaller, but the more you regularly do it, suddenly things start becoming easier. You start feeling that, hey, this is too easy for me, let me level up, let me increase the weight. So that sort of thing, for me, the treadmill or the regularly lifting weights has been my day job. So one of the reasons I have always wanted to run my own software business, that has been my dream right since college for 12 years, I have still not done it yet. Still I am preparing, I am getting more comfortable, I am now reaching the flow state I want. My goal over here, my hope is you don't take that much amount of time as I did. By sharing such tricks, hey, find a day job or be in a situation, be around peers where you are constantly improving no matter what. It's not like the way I think is there are hackathons, these 24-hour, 48-hour hackathons. If you think of everything as a hackathon, you will get burnt out. If you are ready in it for the long game and ensure that there are safeguards in place, like just joining the right job that forces you to learn a language, then your actual mood does not matter. There's a difference between a mood and a motivation. I don't let my mood decide my learning because I'm not that mentally strong enough that I'm always motivated, I'm always having fun. Sometimes I'm just distracted by movies and games and series that I end up not doing things forever. But since I've been finding workplaces and careers over the last several years that enables me to work on these set of skills that I have to improve. In fact, I remember when my current job, I spent a day something like a non-stop something close to 8 hours of a conversation trying to convince my boss why I'm going to choose Elixir. He had all this concern of job, hiring and all those things. I told this is how we solve it. It took me 8 hours. But that effort was needed. So I've been ensuring I'm writing code Elixir on a day-to-day basis. I've also been able to train people. I'm still not reading chat. Okay. Isn't it better to start building? Okay. How do you stay focused on the screen? So for example, this live stream focusing on the screen, I will tell this. I give advice a lot, but it's very hard to follow that advice myself. One thing I keep telling others is don't be perfect. Perfection is the opposite of progress. Keep progressing however good it is. But for this live stream, why I have been delaying is I have done live streaming before and I have had 0 viewers. And when I went and rewatched the content, extremely boring. I dozed off while watching my own video content. It's where I realized that I need to go learn how to become a better speaker, at least correct some basic faults of mine. I might not be the best speaker. How do I get better at it? So for a multi-hour live stream, what I felt was I need to have sufficient content. Still, I have not even crossed the 50% of the content that I wanted to share today. But that can also be intimidating. Am I going to share all of this content today? But what I've realized, this is advice that others keep repeating and I also believe, it's usually the first 5 minutes that are hard. Once you get into a flow state and assuming things are great at your home, that you don't have distractions by others not interrupting you, or you have basic needs taken care of, food and other things taken care of, you can make continuous progress if you get started. But for that you need to know, hey, is this problem meeting my skill level? Are my skills good enough that I can make continuous progress, or is it a tutorial that I have to learn, internalize and come back? That is where estimating problems correctly plays a tremendous role. The example over here, a non-coding example, live streaming, my skills, my preparation were not good enough, which is why over all my free time over the last 2 weeks, I've been preparing for live stream and still I was running into issues. Today I could not blur my screen, like I didn't unblur my screen for the first 20 minutes. I made a mistake like that even when I started. So that is where self-awareness is extremely important, knowing where we are. Moments where I felt I'm a complete beginner, I do not know anything, where I've been able to spend endless hours still growing, is watching excellent YouTube videos. Like for example, the Primagen, he has a lot of content on YouTube. I've been familiar with him for like 4-5 years, but I've never encountered. What I do is, I just put it on my laptop, iPad or somewhere. I might even be doing some passive activity, like say for example, there is this color filling app. It's called Happy Color. I'll just pull it up on the screen. This Happy Color game is all, there will be numbers on the screen and you just have to tap them. It is completely, how do you say, a children's kind of an application, but it's very calming and therapeutic. What I do is, I pay for YouTube Premium so that I have offline videos running. I open this Happy Color, but this Happy Color does not consume any of my brain cycles. I don't even spend time thinking what am I doing, but it gives me some action to do while those videos are playing. I get restless when videos happen. I have to be doing something with my hands, so I just keep tapping these colors and allow that YouTube video to keep playing in the background. My brain is fully on those videos. So that is where I realize, say for example, watching someone like the Primagen, his videos and all those things, his videos are simply just entertaining. I'm having fun listening to his videos. So that way there is still some growth. Again, that is only the having fun aspect of it. Sometimes, say for example, he talks about, he does this commentary on blog posts, right? The building things or doing thing, I would say is, after he has done the full thing, it is my responsibility to figure out some time over the next few days to open that article and go through that article myself and decide whether I agreed upon all those points. It could be just reaction videos, commentary and all those things. So that is what I would do as a beginner, is to follow other people, but for action, tangible hands-on items is what I am trying to cover in Elixir. I am going to come up with follow-on tasks, hands-on modules where you can see results. My recommendation is, even if you do not know programming, if you follow these videos, I know this is the slower route. I don't have condensed YouTube videos. I'm not planning to edit them because I have tried to do them before and I felt miserable doing it. It took me enormous hours to with very little value. So I'm just going to stream and I'm just going to make the streams available. You can just follow along and start doing code. My entire goal is so that you keep getting this feedback loop. You have validation. I'm not going to talk about advanced algorithms, data structures, fancy stuff early in the beginning of my streaming sessions. I'm going to probably schedule them months later, weeks later at least. So I'm going to talk about how do you get results, because that is how I learned as a developer. I believe that's how it is easier for others to learn. So I don't go, I spend some time learn. Motivation is so true, thank you. I want to learn full stack and build LAMP and LAMP stack. I'm a complete beginner. So LAMP, I believe, is Linux, Apache, MySQL, PHP. That is something that I started. Again, this is where I feel community plays a role. I like to use this word a lot, guiding hand. More than the actual knowledge, if I'm seeking knowledge from someone, I should feel confident that they know what they're doing. And if I spend some time with them, I will have success. Unfortunately, in things like the LAMP community or whatever, how many hours I put into it, I have never found a guiding hand or someone to, as an authority figure, to guide me through and promise me results and deliver the results. So it has always been self-explanatory, struggling, oh my PHP thing, some error, some security issue, all these things. It is rather easier to work at low code level like WordPress or something like that is how I struggled at college. All I could do is just basic HTML. Very difficult. So I will say that is where community matters a lot. Community leaders, community tools. When I say community, open source, everyone involved, leaders, tools, videos, content, all those things. In that I have a strong belief. Not my content, ignore. I still feel I have a long way to go. You can follow me along as well. Elixir has fantastic content. My goal over here is to take only the beginner aspects of it and provide them in an easy to consume manner, so that once you start following this, you can, it's more like teaching a man to fish, right? You can go watch those YouTube videos yourself at a later point of time. So my recommendation is full stack, web applications, mobile applications, front end, back end, all those things you can do with Elixir. That is my entire goal. I am a full stack developer. I've been doing that myself. Elixir solves all that problem. We'll get into how it solves all that problem very quickly. The only thing that it probably does not solve is deploying. There is something called fly.io. I didn't have a good experience. You might need some familiarity with the AWS and all those things, which is also something that I'll cover. But my answer to first for full stack development is Elixir. The answer is Elixir. The only difficulty is it can be so good that you might end up disliking writing code in other languages, like JavaScript or something like that. My point is you have to be good enough in all those other languages as well. So please don't go all in on Elixir. We will cover all these concepts. I don't have a Discord yet. I will be streaming on all these channels. I believe you are following me on Twitch. You can maybe set up a notification. I know the follow thing does, but if you set up a notification, probably in a couple of hours I'll be breaking for lunch and then resuming a stream again. Like that you will get to know when I'm covering. My plan is to, the whole point of setting up a live stream is so that I want to be regular with these live streams. The difficulty is I find it very hard to manage a Discord or manage other things. I'm more like I have spent 10x, 100x on the coding side of things. I can't spend 10x, 100x effort on the live stream or video content creation. I'm not able to do that yet. I have not reached that stage yet. I will eventually maybe create a Discord, but my goal over here is to live stream. I'll make these video on demand available on Twitch and YouTube as well. So you can always go through them if you have bandwidth. The only thing negative that I personally feel is I may take a long amount of time to cover simple parts. Say for example, I started several hours ago about Elixir. I still not covered even one line of Elixir code because I've been setting up context. I'm someone who teaches things a little slowly so that people are able to follow along easier. Or I believe someone is asking someone else in chat. I believe S-Boy is asking Joe. You can definitely catch up. You can share details with each other. I'm not against sharing of links on the Twitch channel. Please do go ahead and share information. Now coming back, this is where I feel your programming language should make you think better, so that the amount of lines of code that you write are still small enough for you to keep them in your head or quickly and find out where things are. Now, yeah, Phoenix provides something called as LiveView. LiveView is something like magic. You can build high quality interactive applications just by writing backend code. You don't have to write JavaScript, but there is also something called as LiveView Svelte. Svelte is the equivalent of React. LiveView Svelte combines both Phoenix LiveView and LiveView Svelte. This is something that I am exploring. You can also follow along in building rich interactive applications. LiveView was such a game changer that I believe other frameworks have started doing similar experiences for developers like LiveView. I believe Laravel is doing something like that. Again, I'm not familiar with other frameworks. I'm not up to date with other frameworks. LiveView also enabled newer higher level concepts. I keep talking about these levels, right? There is, if you're not familiar with machine learning and data science, there is something called as Jupyter Notebooks. I believe the name Jupyter comes from Julia, Python, and something else. I forgot what ER stands for. So Jupyter Notebooks is used by data science people, machine learning to build interactive models, learn statistics, all those things. Elixir has an equivalent called Livebook that they built on top of LiveView. So this is where I'm trying to say quickly you can jump up levels once you get good at Elixir, Phoenix, LiveView and all. You can start working with these notebooks, prepare these own notebooks, share your Elixir code for others' consumption using Livebooks. You have to be a machine learning person to just get familiar with learning, sharing your Livebooks. You can share code as Livebooks and other things. Now there is something called as Ash framework that is even more abstract. You can model. It's more like a declarative thing, which we'll cover later, much later. It's early. Now LiveView, I told us you write code on the backend, front end will reflect. LiveView Native is an ongoing project in the Phoenix community where you can build mobile apps. You can build Android and iOS apps that are driven by the server. Again, we'll cover all of this. So the motivation for me to start doing these live streams is I want to become a LiveView Native core contributor. I want to by these streams start all the way from the language Elixir, cover Phoenix LiveView, all those things, and reach LiveView Native so that I can walk through code, cover all of them. Then you may be familiar with tools like WordPress, Wix, Squarespace, which are low-code tools to build websites, right? There is something called as Beacon CMS. A CMS is your content management system. WordPress is a content management system. Again, using LiveView and all, they have built Beacon. I will show a demo of all of this. My goal is to eventually combine Beacon and LiveView so that you can build mobile applications using a low-code interface on the browser. I think this is very much possible if you just consistently build over these things. You can also join me while I build all of this. So it can't be all just theory in these live streams. I'll start writing code at some point of time. So this is what I'll be doing. My eventual goal is to combine LiveView and Beacon CMS. These projects are still not stable yet. They are still in development projects, so a lot of things can break going forward. XUnit is your unit testing library. We'll cover how to write tests for your Elixir code and all those things. There is also, I believe, PropER, property-based testing is a fantastic concept. How can you come up with test cases, fuzzing your test cases? How do you come up with random test cases so that whatever code you write, you can easily check that your code works accurately instead of just trying with basic trivial examples. These are some things that I want to cover. I'll have to keep doing homework in preparation for these live streams so that I'm actually able to do. So if you are getting started, if you want materials and if you are willing to, I'll be covering the online official documentation. I have several of these books. I have purchased several of these books. These books are fantastic, high quality. The creator of Elixir, creator of Phoenix, they write these books in Pragmatic Bookshelf. You can search for Elixir books. My strongest recommendation is to start with this Programming Phoenix book. You need not know Elixir. You can just go through some fundamental Elixir that we cover in this live stream. If you go through this Programming Phoenix, at least the first half of the books, you will get good really quickly. So this is one strong recommendation that I encourage all of you to purchase. Again, it's not an ad, I am not an affiliate, I don't get it. I own this book myself. I also own this property-based testing. Some of these books, I do own this Programming Elixir, but I have not read it through end to end. I'm planning to read on my free time. Due to copyright, trademark, all those issues, I can't read these books on live stream. I'll have to stick to official online content that's available for everyone else. I don't think I'll be doing justice to Pragmatic Bookshelf and the authors if I live stream all these books. But my recommendation is to start in the Phoenix thing. You can start building applications, web applications on top of Elixir in case you don't want to wait for these live stream. Now this is the lay of the land on what I'll be covering over the next several streams, what I'll be building. I'll be showcasing code, walking through code. There's a lot to cover in the first getting started Elixir video itself. The second aspect is going deep into the language itself. So if you see over here on the left hand side, I'm not sure if the font is large enough, but on the left hand side I have two tabs. One is on the application side of things, how you build stuff, more to do with practical stuff, follow along. There is a lot of code to be written and other things. But one can't do just writing code all the time. You will not make progress. There is this famous quote, I spent just 3 days writing code by trial and error. I saved a lot of time by just spending 3 days writing code by trial and error rather than reading the documentation for 5 minutes. It is an approach that all developers take. They want to try it out themselves, that they don't spend time going through the official documentation and end up wasting enormous amount of time. So my point is, you don't have to be spending all the time reading documentation, but at least the core of the language you need to be very strong at, so that you don't waste time struggling around, fighting around with syntax issues. Now we'll get started with Elixir as a language. This is more on the theory side of things. This is not documentation yet. On the theory side of things. Now, one mistake a lot of people make is when they read, say, Elixir is a functional, concurrent, high-level, general-purpose programming, they just gloss over this. I believe that is where, when future statements make references to these jargons, you find it hard to follow along. You stop following along any tutorial, any book, any reference material, because you move forward because it is hard to understand. My point is, if you have energy, if you have bandwidth, please pause, please go through what each of these words mean at a high level. You don't have to read them end to end. At least on Wikipedia, try to make sense of what these things do. Now, if I was reading it for the first time, this is how I will read. Elixir is a functional, concurrent, high level, general purpose programming language that runs on the Beam virtual machine, which is also used to implement the Erlang programming language. If I was reading it for the first time, I wouldn't understand so many things. Now, there is one important differentiation you have to do if you are planning to become a programmer or as a developer. Several times, English words, a lot of general English words are used in a programming context. You should learn to differentiate between these two. Say for example, what does functional mean in English? Hey, something that works. My mic is functional. My mic is functional means my mic works. If my mic is not functional, it means it's broken. I have to go take it for repair. When I say functional in English language, that has a completely different meaning from functional in a computer science jargon or language or speak. That is where we keep confusing the English meaning with actual computer science meaning. You have to stop if it does not make sense. Elixir is not saying, hey, it works. Functional actually means a kind of programming. This is where I say the way you even think about problems will change. I'll cover it. So concurrent, again, it's not the English meaning. Concurrency has some real meaning in the world of computer science. What that means, how is it different from parallelism and all, you need to have some high level understanding. We'll cover it. Again, high level, again, what it means in computer science language, general purpose, what it means, and programming language, we all know what it is. Beam, again, we do not know what Beam means, what virtual machine means, what Erlang means. We'll cover all of them. So I've done the second pass of going through this paragraph, which is, hey, these are computer science jargons. I read it through the first time, so I could not make sense of it because it included a lot of these jargons. Let me go deep into these jargons. Now, this can be boring. Just getting into theory can be boring. You might drift off when I get into all of this, which is why what I'll do is, in this stream right now, I'll just go take a break, have my lunch, and then come back and continue. I'm not going into what functional programming is, what procedural programming, what object-oriented programming. There are two kinds of learning. One is top-down, where you work with what you already have and you keep digging deeper and deeper. Other is bottom-up, where you understand a lot of theory and you assimilate this knowledge and come up with higher level concepts. If you are spending time in programming language theory, that is bottom-up thinking. Bottom-up thinking can be intimidating and boring. At the same time, top-down thinking, sometimes you may not go deep enough. It has to be a mix of both. This is how I'm not planning to create diagrams. I will continue over there. I just want to give the lay of the land, which I have already done. I'll continue to do so. I'll summarize at a high level. Then we'll do one more pass of going through this documentation again. So Elixir is a language. It is also somewhat associated with Erlang as a language. That's all you need to know right now. It was created 12 years ago. Joseph Allen, there is some history of how he started. When he was working at a company called Plataforma Tech, he had worked on an R&D project. He wanted to come up with a new language. He looked for extensibility and productivity. Productivity is the part I try to mention where you simplify. In the Erlang VM, while maintaining So maintaining compatibility, what it means is Erlang has lot of libraries, lot of frameworks. They can just be reused in Elixir. So you might be familiar with Java. There are associated languages like Kotlin, Scala, and Clojure. All those can reuse Java libraries because they run on the same virtual machine. That's how they can reuse libraries. Like that, Elixir can run on Erlang virtual machine. Thereby, Elixir can pull all the best practices of Erlang. Why not use Erlang? We'll cover that too quickly. So Elixir is aimed at large scale sites and apps, which is what a lot of people want to do. They want to build sites and apps at large scale, handle so many users. It borrows from concepts from Ruby, Erlang, and Clojure. So you can see that Elixir is not a level 1 first principle language. A lot of languages have solved problems already. Elixir tries to be a higher level language that adopts the best practices from all these other languages. So handle large data volumes, which means at scale. Elixir is also used in telecommunication, e-commerce, and finance. How do you run Elixir on GPU? We'll cover all of this. So as you can see, there are some basic things in Elixir. So Elixir is a language that borrowed from other languages. This is what roughly the syntax looks like. We'll go through this line by line. Very quickly, I just want to showcase Erlang as a language. Erlang as a language has a lot of, it is providing the foundational stuff for Elixir. Elixir sits on top of Erlang. I will show the diagram. But the difficulty, it was created by these people, very smart people at Ericsson, very nice people, sharing a lot of knowledge. They came up with a lot of fundamental practices, but I can't read this code. This is not intuitive to me. This percentage and dashes, for me, it makes it very hard, double percentage and all, to read Erlang code. I generally struggle with these harsh looking syntax, which is why I started with Elixir. I could have very well started with Erlang. But to me, Erlang code looks harder to read. Elixir code looks simpler to read, which is why I'm doing Elixir. So you can pick up Erlang if it suits you. My recommendation for everyone, Elixir is more like a friendly syntax on top of Erlang. It has its own advantages as well. Elixir tries to do something slightly extra nowadays, but Elixir is mostly Erlang. The reason, even though Elixir just 12 years ago, how can it do all the things that it promises? Because it sits on top of Erlang, which was created 38 years ago and has been used in industry-facing applications. It was developed within Ericsson. That's how Erlang started by these three people. I believe Robert Werding is still very active on Twitter. John Armstrong used to be, but unfortunately he's no more. These people came up with fantastic practices. There are two kinds of way to cover post lunch. After I go have my food, I'll cover these in the next stream or sometime later. There are two aspects on how you look at Elixir. One is just doing hello world, how do I do loops, how do I print this stuff, just getting comfortable with the language. That itself will take some time for us to cover. Then how do I build a highly scalable stuff with Elixir? For that you need to get familiar with these Erlang concepts. There is this Open Telecom Protocol, or OTP, which is a set of libraries that come with Erlang and therefore an Elixir. This is how Elixir can scale. If you can think of Redis, Kafka, all these queuing libraries, RabbitMQ, all those things, they are first party libraries within the language under this OTP, Open Telecom Platform. So I don't have to borrow a library. I just can write code firsthand because of this actor model Erlang provides and all, which we'll cover later. What I'm trying to say is, you can adopt the beginner friendly aspect of Elixir first, get completely familiar with Elixir, which is what I'll be covering initially. Then you can think about how do I leverage the full features of Elixir and Erlang so that I can build highly scalable stuff. How do I build distributed stuff? But for that you need some understanding of distributed systems, distributed concepts, which I'll be covering in the live stream. So I'm not going to cover the advanced aspects of Elixir in the first several streams. We will get started with Elixir. So in a while, this Elixir programming language Wikipedia is what we'll be starting off, and in the next stream I'll probably notify somewhere when the next stream and how much time. So this Elixir programming language is what we will be going through, and then we'll go through the homepage very quickly. In this homepage is a tour of the ecosystem, which I believe I have covered. Then there is this getting started documentation, which is where over several hours we'll have to sit and go through what are tuples, what are lists, what are basic types, why I don't have switch cases, why I don't have for loops. All the things we'll cover. How the language can be extended using metaprogramming. All the things we will cover. What are some good idiomatic approaches? Idiomatic means the recommended way within a language. So you don't want to do anti-patterns, or you don't want to do fancy things and make things more complicated. The official getting started guide is also extremely valuable. This is where this over the last several hours I've just been touching things very broadly at a very high level. So I believe you are all warmed up. In case you are watching this video later on demand, my recommendation is to get familiar. This video was all about setting up context. Now we will start getting deeper. We'll get into theory, we'll get into some fundamental concepts of programming languages in the next stream, or if you are watching them in the next video. Thank you all for watching. We'll resume again in a while. See you.